solve problems on program evaluation and review technique PERT by using first longest path, second critical path.
This table is mentioned in the question. Activity with nodes are given. Optimistic time, that is the shortest time required for each activity, is mentioned in question for days. Then the pessimistic time, that is the longest time required for each activity, is also mentioned, and Tm, that is the most likely time, and which is in between this To and Tp, is mentioned in the question. Now what is the question? Calculate probability of completing project in 55 days. So here we have to calculate the probability of the completion of project in particular number of days. And we will use here the method, PERT method, that is program evaluation and review technique. Now which parameters we have to calculate for using this method? So first is TE, that is expected time. Now if we observe, for each activity optimistic time, pessimistic time and most likely time is given. Now for each activity, how to calculate the duration? So to calculate duration, we will first calculate TE, because this expected time is used as activity duration, and formula is TO plus 4Tm plus Tp by 6. Now I will put the value. So first is 4 plus, so I will calculate here 4 plus 6 multiplied by 4, that is 24, plus 8 divided by 6. So how to calculate this? 36 by 6, that is equal to, I will write here as a 6. So this is the value of TE. Now in the same way we will calculate the duration for activity B. So in here I will take 15 plus 5. So 5 plus 15 plus 7 into 4, that is 28 divided by 6. That is equal to 48 by 6, and which is equal to 8. So in the same way we have to calculate the expected time for other activities. Now next parameter is sigma, that is the standard deviation. So what is the formula to calculate sigma? Tp minus To by 6. So here Tp is 8 minus 4 by 6. So that is 4 by 6. So I will write here as it is 4 by 6. Now in the same way we will calculate for activity B 15 minus 5. So 15 minus 5, that is 10 divided by 6. So I will write here 10 divided by 6. So this is the standard deviation. Now we will calculate sigma square, and which is known as variance. So how to calculate this variance? Sigma square, that means we have to take numerator square and denominator square. So here 16 by 36. Second, it is 10 by 6, that is 100 by 36. So in the same way we will calculate all the parameters for other activities. Values of expected time T, standard deviation sigma and variance sigma square is calculated for all the activities. Now next step is to draw the network diagram. So for activity A, node 1 to 2 is given. So I will show here node 1, and then the next node is node 2. So for activity A, we will refer duration as a TE, and that is equal to 6 days. Now if we observe next nodes, then node number 2 to 3 and 2 to 4. That is, there are two branches we have to draw, 2 to 3 and 2 to 4. So I will show here 2 to 3, 2 to 4 for activity B and C, which is having duration 8 and 8. So we have to mention duration also. Now for activity B, it is 3 to 5, and for E it is 3 to 6. That means from 3 we have to show two branches, that is 3 to 5 and 3 to 6. For 3 to 5 it is activity D, and here is E. it is 20 days duration, and E it is 18 days duration. Then 4 to 6. So we have to join here 4 and 6. That is activity F, and it is 10 days duration. Then 5 to 7. For activity G, and it is 8 days duration. For activity H, it is 6 to 7, and it is 2 days duration. And then 7 to 8, that is activity I. It is 7 days duration. So this network diagram is getting completed. Now what is the next step? So next step is to find out the various possible paths. That means we have to find out the paths starting from the node 1 and it will end at the node 8, because this is the node 1, that is the start node, and this is the end node. So how many paths are there? So we will find out that. So here is 1, 2, 3, 5, 7, 8. So this is the one path. Then if we observe at 3, there are 2 branches. So again we will write 1, 2, 3, 6, 7, 8. And now from 2 also there are 2 branches. So here 1, 2, 4, 6, 7, 8. Now these are the possible paths when we start from the node 1 and it will end to the node 8. Now we will calculate the duration for each possible path, and from that duration we have to find out the longest path, because this question we are going to solve by using the longest path. So how to find out the duration? So 1 to 2, it is 6. So I will write here in rough 6 plus 2 to 3, that is 8, plus 3 to 5, that is 20, plus 5 to 7, that is 8, and 7 to 8, that is 7. So we have to add this. So 8 plus 8, 16, plus 20, that is 36, plus 13, that is 49. So we will write here as a 49. Now next 1, 2, 3, 6. So 1, 2, 3, 6. So I will write here 6 plus 8 plus 18 plus 6 to 7, that is 2 plus 7. So again we will add this. (41). Now we will move next 1, 2, 4, 6. 1, 2, 4, 6, 7, 8. That is 6 plus 8. 14. 14 plus 10. That is 24. 25, 26. And 26 plus 7. That is 33. So these are the durations. So how to find out the longest path? The path which requires the maximum duration. So this 49 is having the maximum duration. Now this is the longest path, and we have to find out what is the variance of the longest path. So variance, that is sigma square, is we have calculated for each activity. So how to add this? So how to find out? So this is the longest path. So 1 to 2, for 1 to 2 sigma square is 16 by 36, plus 2 to 3, it is 100 by 36, plus 3 to 5, it is 100 by 36, plus 5 to 7, so here is 5, 64 by 36, plus 7 to 8, 4 by 36. So we have to add these to calculate the variance of the longest path. When we calculate, variance is 284 by 36, and which is equal to 7.88. Now we will calculate the standard deviation of the longest path. That is under root of this sigma, that is equal to sigma is equal to, we have to take under root of 7.88 and which is equal to 2.8087. Now we will move to calculate the normal distribution. So how to calculate this? So we have different parameters. So first one, x is equal to duration given. So duration mentioned in the question, that is equal to 55 days. So this value is x. Then d, duration of longest path. So here this is the longest path and which is having duration 49 days. So this is the value of d. And sigma, standard deviation of longest path. So we have calculated sigma, that is this is the standard deviation of longest path and that is equal to 2.8087. Now we have formula normal distribution z is equal to x minus d by sigma. So when we calculate, we will get the answer 2.13. So we can write this value in second way, 2.10 plus 0.03. Now why to split this value? So we have to split this value in this way. Because there is one chart, so we have to refer this chart. So if we observe on the vertical line, values are given 0.0, 0.1 and then 1, 1.1, 1.5, 1.6 etc. So our first parameter is 2.10. That means we can refer here 2.1. So on vertical line we will select the value 2.1 and on horizontal line we will select the second value 0.03. So if I move horizontally in front of 2.1 and vertically 0.03, then we will get the value 0.9834 and this is the value of standard deviation z is equal to 0.9834 and this is the answer. This is the second question. Here the nodes are mentioned. Optimistic time, pessimistic time and most likely time is also mentioned. Now as in the previous case, we have to calculate the parameters expected time, that is TE, standard deviation sigma and variance sigma square. So I have calculated by using the same formulas as mentioned in the previous question. Now if we observe the question, first find the probability of completing project in 27 days. And second question, find out the critical path. Now if we find the previous question, then there it is not mentioned to find out the critical path and that's why we have used the longest path to calculate the normal distribution. But in this question we have to find out critical path. So we will use the critical path to find out the normal distribution. So what is the next step? So next step is to draw the network diagram to find out the critical path. So I will first take the nodes and we have to refer expected time for the duration. So node 1 to 2, 1 to 3, 1 to 4. That means from the starting node 1 there are total 3 arrows we have to draw. So I will take here 1 to 2, 1 to 3 and last one 1 to 4. Now we have to take the duration. So 1 to 2 it is 7, then 1 to 3 it is 6 and 1 to 4 it is 14. So this duration is in number of days because here the question is that we have to find out the probability of completing project in 27 days. So we have to show arrow also. Now we will move next, then 2 to 5 and 2 to 6. So we will write here again two branches for 2 to 5 and 2 to 6. For this 2 to 5 it is 5 days expected time and 2 to 6 it is 11. Then next one 3 to 6. So we will join here 3 and 6. So for 3 to 6 duration is 7 days. Then 4 to 7 and 5 to 7. So here is node 5 and here is node 4. So we have to take the node 7 as we have to join 4, 5 and 6. So here is 4, 5 and 6. So I will take, this is the end node 7. Now I will join this 4 to 7. So for this 4 to 7, its duration is 11. Then 5 to 7, so we have to join this 5 and 7. And for this duration is 4. And 6 to 7 duration is 5. So this diagram is getting completed. Now we have to find out the critical path. So for that we have to find out the earliest start and latest finish, that is the ES and LF value. So first we will calculate ES starting from node 1 and ending towards the node 7, because this is the start node and this is the end node. So at this node 1 ES is always equal to 0. So how to find out? So at the node 2 I will take here ES. So there is only one arrow. So 0 plus 7, 7. Then we will take the next node, that is the node 3. So ES is equal to. So at node 3 there is only one incoming arrow. So 0 plus 6, 6. And at node 4 ES is equal to 0 plus 14, 14. Now we will move next, that is after node 4 there is node 5. So at node 5 ES is equal to. So only one incoming arrow. So 7 plus 5, that is 12. At node 6 ES is equal to. Now here two incoming arrows. So there are two values. So or two options. So 6 plus 7. So first option is 13. 11 plus 7. That is second option is 18. Now we have to choose the highest value. So highest value is 18. Now at node 7. So there are three incoming arrows. That means there are three options. 14 plus 11, that is 25. Second option 18 plus 5, 23. And third option 12 plus 4, that is 16. So we have to choose the highest value. So in between these three ES is equal to 25. Now we will calculate the value of latest finish, and we have to move from this end node towards the start node. And at the end node value of LF is equal to value of ES, that is LF is equal to 25. Now we will move next node, that is the node 6. So from this node 6 only one arrow is starting, that is only one starting point for the arrow. So here 25 minus 5. So here LF is equal to 20. Now at node 5 there is LF is equal to, so only one arrow starting. So and this arrow is having duration 4. 25 minus 4, that is 21. Now after that node 4 LF. So here is only one arrow starting. 25 minus 11, that is 14. Now we will move next, that is the node 3. So here LF. So here also only one arrow starting. So if we observe, this arrow moves towards the node 6. So 20 minus 7, that is 13. Then again at node 2. So there are two arrows starting. That means here two options are available. So first is 2 to 6. So 20 minus 11, that is 9. This is the first option. And second option 21 minus 5. So 21 minus 5, that is 16. So we in between this 9 and 16 we have to choose the lowest value, that is 9. So I will take LF is equal to 9. Now again if we observe at node 1 there are three arrows starting, that means three options. So here 14 minus 14. So first option is 0. Second option 13 minus 6, 7. And third option is 9 minus 7, that is 2. So we have to choose the lowest value, that means LF is equal to 0. Now at this node 1 value of ES is equal to 0 and LF should equal to 0. So if we observe our cross calculation, that is correct because LF is equal to 0. Now how to find out the critical path? So for that we will calculate the slack. So slack, that means positive difference in between the ES and LF. So we will calculate the difference. So at node 1 it is 0. Here what is the slack at node 2, that is 9 minus 7, 2. At node 3 it is 13 minus 6, that is 7. At node 5 it is 9. At node 6, 18, 20 minus 18, that is 2. At node 7 S is equal to 0 and at node 4 S is equal to 0. Now we have to find out the points for slack is equal to 0. So it is 1, 4, 7. Now we will connect these points. So I will connect with the help of red marker. So this is the critical path 1, 4, 7. Now what is the duration of critical path? So how to find out this duration? So duration for critical path 14 plus 11, that is 25 days. Now we will calculate variance of the critical path. So critical path is 1, 4, 7. So for 1 to 4, variance sigma square is 16. And for 4 to 7, sigma square is 16. So 16 plus 16, that is 32. Now how to calculate the standard deviation sigma for this critical path, that is square root of 32, which is equal to 5.66. Now we will find out the value of normal distribution. So for normal distribution, Z is equal to x minus d by sigma. So this x, that is we have to find out the probability of completing the project in 27 days. So here x is 27, d, that is the duration of this critical path, that is 25, and sigma, that is the standard deviation of critical path. So here we have to refer the values for d and sigma for critical path instead of longest path. So after calculation, which is equal to 0.35. So to find out the value of Z by using table, we have to split this value. So how to split? 0.3 plus 0.05. Now if we observe, this 0.3 is given on these vertical lines. So we have to refer this 0.3 and 0.05 is given on the horizontal line. So if we check the point of intersection, then that is the value of Z and that is equal to 0.366368, and this is the answer.